Hello everyone. I hope you all are doing well, and thank you so much for attending today's seminars, where I'm gonna present PARSAN-Mix, which includes new methodologies for latency optimization in mixed network. So to this end, I'm gonna first briefly introduce anonymous communication system and the necessity of having them on internet. And then later on, I will discuss some of the issues of mixed network as a type of anonymous communication system. And subsequently, I'm going to introduce PARSAN-Mix methodologies to, resolve these challenges or issues. And eventually, I will conclude the talk by mentioning some key results of PARSAN-Mix. So as you might know, usually on internet, when two endpoints want to communicate, their communication will be protected or secured with cryptographic operations like end-to-end encryption. But actually, the fact that these 2 points are communicating is not protected or hidden from the perspective of a network adversary observing such scenario. And it can actually create some privacy issues that we need to address. To address this anonymity issue, one of the typical choices is to use Tor network. The Tor network actually is an overlay network on internet, which consists of many nodes that are usually known as Tor relays and categorized as guard, middle, and exit relays. And in this scenario, if a client wants to make a communication path to have an anonymized connection to a destination, we'll simply pick one exit, middle, and guard relay and participate in some key exchange algorithm to exchange some keys with the exit, middle, and the guard relay. And afterward, to forward these passages through these relays, the client requires to, encrypt the packets with the keys that have been exchanged with the exit, middle, and guard relay respectively. And in such settings, each intermediate relays after receiving the packets will peel off one, actually peel off one layer of encryption and forward the packets to the succeeding relay. So Tor, in this setting, will provide anonymity for the client to the destination connection under 2 critical assumptions. The first assumption is that this guard relay and the exit relay are not owned by the same entity. And the second one is that the internet service provider who observes the communication network between client and the guard relay is not the same as the one who owns the network between exit and the destination. And as you might guess, if the latter is the case, we have a problem. So basically, the anonymity can be compromised in this case, because the internet service provider can gather information regarding the packets entering to and going out of the Tor network, and can later use some neural network techniques to launch correlation attack, which unfortunately has been shown with high accuracy can tell who communicates with whom. So, not so good. We need to have a better approach to provide stronger anonymity. To do so, first let's have a good understanding of mixed node. So you can consider mixed node as an entity on internet which receives packets from different clients, and will shuffle or delay those packets and flush them out. And in that scenario, an adversary who observes like input and output of the mixed node will have no clue how to map the input to the output traffic. So helping us to mitigate such adversarial behavior. To be more precise, usually we use mixed node in a network that we call it mixed network or mixnets. And typically, we form the mixed node to be in layer formats. And in such scenario, one client can pick one node from each layer to make a communication path for forwarding a packet. And now the internet service provider can easily, can corrupt all parts of the network, as you can see, but still he cannot say who communicates with whom. So the anonymity will be provided. Even we can go to the extreme and consider this internet service provider to even corrupt these mixed nodes. And even in such case, as long as one mixed node is trustworthy along the communication path, the anonymity will be preserved. So that's great because we had an anonymity issue on internet. And now using mixed network, we could perfectly address that. That being said, mixed network provides such anonymity at the cost of high end-to-end latency. So that's the downside of the using mixed network. Basically, the latency is high as a result of performing shuffling or mixing process inside the intermediary mix nodes. Another reason for high latency is that instead of forwarding the packets directly to the destination, the client selects 3 intermediary nodes to do so. So these intermediaries actually can be very far from each other, which will further contribute to the high end-to-end latency. However, we realized in PARSAN-Mix that these two are not the only sources of high latency. Actually, there is another issue in mixed network compared to Tor. So basically, imagine that the client wants to send a message. Usually, client need to divide them in few packets. And in mixed network, each packet will follow a distinct path. And this will actually worsen the scenario, because if she wanted to send just one packet, this packet might go through high latency path, but the chances was less. But if you have a message which consists of 10 packets, the chances of one of them going through the high latency path would be really high, exponentially high. And unfortunately, the destination also should wait to receive all the packets, even the latest packets, to be able to fully detect the message. And that's why end-to-end latency is very high in mixed network. So we consider this issue and try to resolve it in PARSAN-Mix because it's very important. If it's not addressed, then client cannot adopt mixed network for instant messaging or web browsing. So to address this, in PARSAN-Mix, generally we introduce 2 methodologies. The first methodology is packet aware routing, or PAR. So basically, in this case, we recommend to the client to be aware of the number of packets that exist in one full message. So if she wants to just forward one packet, it's okay to uniformly at random select the nodes from different layers. But if you have more packets, you need to be careful and you need to make sure that the communication paths are very low latency, meaning that the distance between nodes is not that high. And also, for each packet, these paths are kind of similar to make sure, in the end, the latency would not be so bad. Apart from this, we provided another approach that will not take into account the routing process, but instead the mixing delay that will be introduced by each mix node. So in more detail, as you might remember, I said that mix node will shuffle or delay the input messages or packets to perform unlinkability, to provide unlinkability. Usually, this process, like in mixed network, will be done considering a probability distribution. Here we consider, for example, an exponential probability distribution. And this distribution can be tuned based on its average, right? If you have one message, it's okay to have a high average, but when you increase the number of messages, again, this actually probability distribution might have unpredictable average. So better to reduce the delay, actually. But as a result of reducing the average mixing delay in this approach, the anonymity will directly be compromised. Because if you have less delay in mixed node, that means that you will have less packets together and the mixing kind of will be damaged. To account for that, in this approach, we consider generating cover traffic by clients. So actually, cover traffic are fake messages or packets that client will send it to herself or himself, just with the goal of making sure that each mixed node will have enough packets in its pool to provide still high anonymity. Okay, so after defining these two methodologies, we also consider some metrics to kind of quantify the effectiveness of PARSAN-Mix approaches. So one of the metrics we should always take into account is anonymity. Because when you are trying to change the methodologies in mixed network, it's really easy to damage or compromise anonymity. To do so, basically to quantify those compromise, we consider like a scenario where there is a global network adversary who observes all the part of the network with the goal of de-anonymizing the messages, like the message, clients and destination connection. In this scenario, this adversary might target an input mixed node in the first layer of the mixnet. And we'll see what probability messages entering, or let's say packets entering in these mixed nodes will come out of any of the nodes in the last layer of the mixnet. And the entropy of that probability distribution would be our metric. So if you think about it, by default in mixed network, this metric would be as high as possible because message routing happens uniformly at random. But when you try to change the routing, that metric will be reduced. So good to have a look at it. Apart from that, we also consider the latency, like how average latency will change when we use Parsan-Mix approaches, because it's very important. In first place, we wanted to reduce the latency. So to do that, we consider all the paths that one can consider in mixed network together with their imposed latency. And later, we could easily estimate the expected value of the latency to just take a look to make sure that the latency reduction is good enough. Okay. So, yeah, after having both the methodologies and the metrics defined, then we can move forward to see one of the key results of the Parsan-Mix. So basically, I've performed many experiments, but here I will just show you the main ones concerning both packet aware routing approach and managing shuffling delay approach. So a client who wants to optimize the latency in mixed network can use packet aware routing approach. So this approach can moderately reduce the latency, like 20%. That's good. And on the other hand, the anonymity will not be reduced that much, just 1.2 bits of anonymity, which is not that bad considering the latency reduction. And the good things about this approach is that the computation overhead is not that high. Like the client does not need to do many things to come up with this new routing methodologies. They need few adjustments to select a path based on Parsan-Mix. On the other hand, the managing shuffling delay or MSD approach can dramatically reduce the latency, like 52% reduction in latency, which is actually great. And the crazy thing is that you actually will not lose much anonymity here. Almost you can say that the anonymity loss is negligible. But unfortunately, this approach requires high computation overheads for clients. So basically, these two approaches in PARSAN-Mix can give a free hand to the client. The client should make a decision. If they have enough computation resources, definitely they can go after this approach. But if they don't have, it's better to use packet-aware routing approach. So it's kind of a balance that they can make a choice. Okay, so in a nutshell, in this talk, I brought up this point that on internet we have anonymity issue regarding the end user's identity. And one of the ways to address this is to use Tor network. But unfortunately, Tor network is very vulnerable to the network adversaries observing both ends of the network. To address this, one can consider using mixed network, but usually mixed network damage the quality of communication. So if you want to have high quality of communication and enough anonymity, at least better than those of Tor network, you can definitely use PARSAN-Mix, which also reduces the latency up to 52%, which is great. Yeah, so that's all I wanted to talk about. Thank you so much for attending and listening to my talk. Feel free to see the paper in my webpage or other related paper or blog post. And if you have any feedback or question, please feel free to give me. Thank you.